Now, people often ask about float, which is sometimes also just called slack, or they might be talking about a delay on a project, and there's some confusion there, and you're not wrong to be confused. I'll explain why with this simple example. So we've got some simple activities, we've got a start on the left and a finish on the right. Now, in our technique, we're always told in the textbook to draw some boxes. So here are my boxes. Boxes at every node. And remember, the boxes are for the dots, not for the lines. The activities are the lines. And so we're going to do our forward pass. And we're always looking for the max, and we're adding. So we've got 0 here at the start, and we say activity A has 3, so we add 3. And we go down the bottom for D, 3 plus 3 gives me 6. Now going across B, when we're coming to this node over here, you can see that we've got a 2 coming in. So we're going to say 3 plus 4 is 7. I'm not going to put it in the box yet. We've got to work out the maximum. And then we've got 6 plus 5 is 11. So we can clearly see then that the maximum is 11. So I put 11 in that box. And then 11 plus 2 is 13. All right. Then we've got to do our backward pass, and we're looking for the minimum, and we're subtracting. So we do 13, and 13 minus 2 is 11. Going back against the arrows, 11 minus 5 is 6. 6 minus 3 is 3. I put the number here because I'm not sure. And then you've got 11 minus 4 is 7. So I choose this time the minimum between 3 and 7. Well, that's 3, and 3 minus 3 is 0. And all good so far. And then I'm just going to use the highlighter pen. And obviously, this has to be on the critical path because it's the only route. And we have to include all the boxes where the numbers are the same. And what you'll notice here is activity B, even though the beginning of B and the end of B, the numbers are the same, activity B is not on the critical path, and it's not shown anywhere with the boxes. Now, sometimes in the textbook, it'll say things like, if there's more than a couple of lines coming out here, so like at the start you had 3 lines, you should do 3 boxes. But actually, that should be done on every single part of the activities. So the point is here, if I was to ask you the question, what is the float on B? Well, it doesn't look like there's any float, but clearly there must be a float. It's not on the critical path. And it's because of these triangular formations you got here. So if I was just to do that in a different color, this kind of triangle where the beginning and end of B are on the critical path, those nodes, but the actual activity isn't. And that's where you get that confusion from. So I should put that the highlighted cut back. Oh dear, I'm getting all wrong here. There we go. Okay, so this is a question from the 2018 Northern Hemisphere exam 2, question 4, and we're really looking at part C. Now I've done a separate video about this, but I just want to focus on this. And part C, it does actually tell us that the value of P is 6, so it'll help us out. And I just wanted to focus on this idea of the critical path. So this is just to emphasize the critical path. Now, even though we've got 3 things coming into the start, I am just going to draw one box. And it will work fine just doing one box. So we do all our boxes, and the boxes are for each node. Then we've got to do our forward pass, which is the maximum, and we're adding. So 0 plus 3 is 3. Then we can go to the top. 3 plus 4 is 7. We've got to come down from there. We've got a 12, but we've got a 3 plus 1, which is 4, and we've got a straight 5. So we choose the maximum, which is 12. Coming down, we've got 18, and then a 2. Obviously, 18 is bigger, so we choose the 18. Coming down from the top again, 7 plus 10 is 17. 18 plus 6 is 24. I choose the 24. Going down, 28. 18 plus 5 for the J is 23. So 23, 28, I choose 28. Whew. Should be fairly quick with that. All right, minimum is subtraction. So we start with 28. We go backwards, we get 24. We go backwards along J. 28 minus 5 is 23, but 24 minus 6 is 18. I choose the 18. Going back up, 18 minus 6 is 12. 18 minus 2 is actually 16, but I'll leave that for the moment. Let's go all the way back up to the top. So along H, you've got 24 minus 10 is 14, but coming from this middle dot up, we've got 12 minus 5 is 7, so I choose the 7. 7 comes down, minus 4 is 3. That's probably going to be the right number, but if we do 12 minus 4, we get 8, so I definitely choose the 3. We've also got a 5 coming, a 7. 12 minus 5 is 7, and then 3 minus 3 is 0. So between the 0, the 7, and 16, I choose the 0. Whew. Now, when we do the critical path analysis, there's lots of paths we could choose. There's only one that will include all the ones where the boxes, the numbers are the same. So 0, 0, 3, 3, 7, 7, 12, 12, 18, 18, 24, 24, and 28, 28. Okay. So that looks pretty good, but the question is actually asking the float time of H. So float time of H. So what is the float time of H? Now this goes back to what we were saying earlier, or I was saying earlier, not we. And we've got a triangle here, and H is on that triangle, and the beginning of H has 7, 7, and the end of H has 24, 24, but H itself is not on the critical path. So when you're trying to work out the float, it just doesn't seem to be there, does it? But it is there, and we'll look at it in all the possible ways. So one of the easiest ways to look at it is, remember we said the difference between the green numbers? Well, that's 24 and 7, so that gives us a 7. Or it was here with the red numbers, 7 and 14. That's also 7, yes? So both of those differences coming into that node show the difference between those two paths. So what you're really doing is just saying, from this point going down here and here, well, that is 5 for the F, 6 for the G, and 6 for the I. So that makes a total of 17 for that path. If we go another path, which is just straight down H, it's just 10. So even those two numbers, 17 and 10, if you're just comparing the length of the two paths, you can see clearly that the float time is 7. And that's how you look at float time. Just compare the two paths on the things, but they'll often show this in. It's from the 2018 Northern Hemisphere exam to question 4 part C, where they've done that thing where the float time is not apparent from the diagram because the start and end of the activity are both on the critical path.